Hey everyone, and welcome. If you've ever found yourself wrestling with threads, mutexes, and locks in C++, you know that concurrent programming can be, well, let's be honest, it can be a real headache. Today, we're going to look at a much friendlier, way more elegant approach to building powerful, concurrent apps using something called the actor model and an awesome tool called the C++ actor framework. Okay, let's jump right in.
So here's our plan for today. We're going to start with the big idea. What exactly is the actor model? Then we'll see how the C++ actor framework, or CAF for short, makes it happen. We'll code up our very first actor, then scale that up to a super useful worker pool pattern, watch it chew through a real problem, and finally, I'll share some key best practices to get you started on the right track.
All right, before we get into any tools or code, let's talk about the philosophy here. Why do we even need a different way to think about concurrency? Well, the old way forces us to juggle shared memory and all these complicated locks just to stop things from blowing up. It's a way of thinking that honestly leads to fragile code that's a nightmare to debug. But what if we could just change the rules of the game?
Exactly. The whole point is to tap into all the power of our multi-core processors without falling into the classic traps, like race conditions and deadlocks. This is really about a shift in how we think. We want to stop worrying about all those low-level details and start thinking about our high-level workflow.
And this is where the actor model comes into play. What's so great about it is just how simple the core idea is. It's all about these isolated, independent things called actors. They don't share memory, they don't mess with each other directly. The only way they talk is by sending messages, kind of like sending emails back and forth.
This right here is my favorite way to picture it. Just imagine every single actor is a tiny, super focused employee. It's got its own private notes, its own data, and a personal mailbox where it gets new tasks. It just pulls one task at a time from its list and works on it, completely undisturbed. That isolation? That's the secret to avoiding all that synchronization chaos.
So let's walk through that flow. First, a task shows up in the actor's mailbox as a message. Second, the actor gets to work on it, using its own internal state, and nobody else can peek at or change that state while it's busy. And third, once it's done, it might send a message to another actor, maybe passing on a new task, or it could even create a brand new actor to help out with the workload.
So that's the theory. And it sounds great, right? But how do we actually do this in C++? Well, that's where our main tool for today comes in, the C++ Actor Framework, or CAF. CAF is this amazing, mature, open-source library that brings the actor model to modern C++. Its actors are super lightweight, way cheaper to create than a full operating system thread. The message passing is crazy fast and optimized. But the best part? It completely handles all the thread management for you. You just focus on creating actors and telling them what to do, and CAF Scheduler figures out the best way to run them across all your CPU cores.
Now, this is CAF's secret sauce, and it's brilliant. Imagine one CPU core finishes all its work and is about to just sit there doing nothing. Instead of letting that happen, the work-stealing scheduler lets that core's thread go look at the to-do lists of other, busier threads and, well, steal a job. It's a simple idea that makes sure the work is always spread out evenly, keeping your whole system running at full speed.
Okay, that's enough theory. The best way to really get this is to see it in action. So let's look at some actual code. You're going to be surprised how little it takes to get your first actor up and running. Check out this little snippet. First, we define the actor's behavior. In this case, it's just a simple Lambda function that takes a string and returns a nice greeting. Pretty simple. Next, we use system.spawn to bring that actor to life. And finally, we send it a message with request. We're asking our greeter actor to handle the string world, and that .then part at the end, that lets us handle the reply whenever it comes back, without freezing up our program.
And this is the magic moment. Look at that code again. What's not there? You don't see any std thread, no std mutex, no std lockguard. We just described what we wanted to happen, and CAF handled all the messy details of how to make it happen concurrently. That's a huge simplification, and it's just a better way to write this kind of code.
Okay, so a single actor is pretty cool, but the real power of this model just explodes when you start organizing actors to tackle bigger problems. And one of the most common, most useful patterns out there is the worker pool.
The idea is actually really straightforward. You have one main actor, let's call it the dispatcher. Its only job is to take in big tasks and then delegate the actual work to a whole group, or a pool, of identical worker actors. This is an absolutely fantastic pattern for any job that you can break down into smaller, independent chunks.
So here's the play-by-play.
a big job comes in to the dispatcher. The dispatcher acts like a project manager and just slices that big job into a bunch of bite-sized pieces. Then it starts handing out those pieces, one to each available worker in its pool. Each worker chews on its little piece of the problem at the same time as all the others, and when it's done, it just sends its result back to the dispatcher. It's a classic divide and conquer strategy, and it fits the actor model perfectly.
All right, let's make this super concrete with a quick little demo. We're going to use our new worker pool to tackle a simple problem that can really bog down a single thread.
So, imagine, we need to find the sum of a gigantic array. I'm talking millions and millions of numbers. If you do this with a single thread, it has to slog through every single element, one by one by one. We can do so much better.
So our dispatcher actor takes this massive array and just chops it up. For our example, let's say we have 10 worker actors, so the dispatcher splits the array into 10 smaller chunks and sends one chunk to each worker.
And here's the payoff. Because CAF's scheduler is smart enough to run these actors on different CPU cores, all 10 of our workers can be calculating the sum of their little chunk at the exact same time. We're literally doing 10 pieces of work in the time it would have taken to do just one.
Once each worker finishes its calculation, it sends its subtotal back to the dispatcher. The dispatcher's last job is the easiest part. It just has to add those 10 small numbers together to get the final grand total. And just like that, we've solved the problem in a fraction of the time.
Now that you can see just how powerful this approach is, let's wrap things up with a couple of crucial rules of the road. These will help make sure your journey into actor programming is a smooth one.
Okay, this is the single most important thing to remember. Remember how all our actors share a limited pool of worker threads? Well, if one of your actors does something slow and blocking, like waiting for a file to download, it ties up that entire worker thread. No other actors can run on that thread until it's done. So the takeaway is simple. Keep your actors fast and non-blocking. Think in events. Send a request and let the actor send you a message back when the result is ready.
So if this has got you thinking, the best place to go next is straight to the source. The official website, actorframework.org, has everything you need to get going. The user manual is incredibly detailed, and the official GitHub is packed with tons of great examples to learn from.
So we've seen how the actor model, with a little help from CAF, really boils down concurrency to just sending messages between these little independent workers. It lets you focus on your app's logic, not on the nightmare of locks and threads. It basically hands you an entire army of concurrent workers. So the only question left is, what are you going to build with it? Thanks so much for watching, and feel free to drop any questions down in the comments.